cover. So it all started from Unix, where it had the concept of streams. Okay, those who are familiar with Unix would know it, where the underlying data, whatever they treat them, like it can be files or it can be on sockets. So they actually always treat them as a stream of data flowing in, right? So that's what, if you really look at the way how Unix structured its commands, you'll be able to actually pass these streams from one command to the other commands, where you use symbols like pipe, redirection. You can do all that stuff. The concept was inspired by the way how normally the streams work, right? In the real time, your water stream, how it actually flows. So they felt that data inherently have this sort of nature. Data which is being processed by one application or one program will tend to be processed by some other application. Then that application will actually process them and may perhaps transform the data or do something about the data and produce something else. So then it will be again fed into another system. So they felt that it actually behaves more like streams. So they came out with an abstraction called streams and sockets, as I explained a slide before. So they actually worked as an abstraction when it came to networks. So which is pretty similar to how files were handled in Unix. Okay. So that's where it all began, where they actually gave you a feeling that, hey, there is a possibility of connecting different devices, but you still treat them as if you are able to access those resources as well. But finally, if you look at it, what's really doing, like now I'm just bringing you into the current architecture of big centers, data centers, or large systems. Finally, all the pieces of hardware, you call any of them, say storage, a grid of servers, cables, switches, routers, firewalls, wireless, whatever it is. Okay. After all, what do? They carry out instructions and move data. And finally, the Turing machine, which I originally mentioned, right, where you are expected to have a huge amount of memory available to you, and you have some infinite processing capability available to you. So that is made possible with the help of networks. But all of them finally do only one thing. They either carry out some instructions or they keep moving the data between various systems. In short, or in a new perspective, if you look at it, it is all about creating one such seamless large notebooks for each one of us, so that each one of us gets a feeling that I have infinite resources with me, because I have lots of need to store data, to retrieve data, to communicate with my friends or buddies or to whoever I want to know. So, and moreover, I want to always stay connected with my people as well as to all this information that are available, right? So finally, we are actually moving into a world where this is going to be made possible. So that's what makes the network operating system very interesting and very challenging. So now suppose if we really talk about the same code, right? So earlier we saw that the code inside a notebook is determined, the complexity of the code is determined by the space and time. However, in this infinite notebook, there is one aspect that we cannot ignore, is the network. That's the third dimension. So earlier when we write any application, we used to always measure the space it takes and the time it needs to run, right? But now if you really look at it, most of them are online driven, right? So people always ask you, okay, it takes so much of space, it takes so much of time, but what's the network bandwidth it's going to use, or what's going to be the delay in the network? How much you're going to account for the performance of your system. Okay, so how these networks are built? Okay, so this is where the concept of protocols come in, where protocols actually provide the foundation on which the networks are built. So I'm not going to go into the details of all these protocols. I assume that you know about OSI 7 layers. Each layer has got a set of protocols through which the entire the networks are built. And network OS, what primarily it does. So while networks provide the foundation for networks, while protocols provide the foundation for networks, network operating system provides the foundation on which these protocols run. Okay, so that makes it slightly different. So this is where we need to understand how things are shifting a bit. Earlier the operating system's primary concern were sharing the resources, and the focus was more on computing. Okay, whereas on the network the focus is more on communication, right? So now we need to transition these operating systems or adapt these operating systems in order to support powerful communication features as well. So what are the challenges? Of course, quickly we can immediately relate to it, where there is a paradigm shift